Today we will be solving Leetcode 1601, that is maximum number of achievable transfer requests. It is a hard question, but I don't think this is a hard question because we can do it pretty easily. But there's a concept behind it, like how will you go through all the possible combinations of requests. So let's just start from the description. So it says we have n buildings number from 0 to n minus 1. Each building has a number of employees. It's transfer season and some employees want to change the building they reside in. Alright, fine. And I've been given a request that is people are moving from to 2i, and it's just saying the number of people entering a building. This is, it should be equal to the number of people leaving the building. This is what it means to say. So it basically says that the degree of the chosen indexes should be equal to the out degree of it. Like if I have one have an degree of 3, that means 3 people are entering inside it. And for the room number 3, for the people that are moving out from the room number 1, that should be equal to 3 also. So this is a basic idea behind how we will solve this problem. And now it says like you can choose some number of requests, like how many requests you can process. To process request, you have to choose some requests from it. Like I've chosen some requests, like this is 01, the first request, and that's gonna be 10, that's 01, and it's 12 and 20. So in the first case, I choose it, I left it, I choose it, I create a in degree and out degree from it. Like for the 0 part, 0 is going into 1, so 1 will have its in degree getting increased by 1, and 1 is going to 0. 0 will also have an in degree going to 0, and out degree of 1 is increased. So if it's like written as 0 1, then it should be in degree. So if it's written as 0 1, that means we have to increase the in degree of 1, and out degree of 0 should be 1 because the edge is moving out from 0 to 1. At the end we will check all the numbers, all the rooms, and if all the rooms have its in degree equal to out degree, that means the net flow was 0. So now one thing comes into mind, like what are the possible combination that we should choose from here. We can use DFS to track the possible combinations and can use a visited array, but it will be too long and it will consume a lot of space. So we will use mask because the number of requests is up to 16. So basically if it's up to 16, that means should be one left shift 16 mask we can take. So it will be like 0 0 0 0 0 up to 16 times. So it can be used as a visited array in terms of mask. So what we'll do is just we run through a DFS and we can do the take or not take part, and we'll create all the masks. We'll create all the masks through DFS, and the second part is we go through the mask. So if we have mask like 1 1 0 0 1, that means the 0th index is selected, 1 2, that's third index is selected, fourth index is selected. Like we have this, these are the indexes that have been selected according to this, and third and fourth, that should be 1 2 and 2 0. So from this we create the in degree and out degree graph, and if net flow 0, we count the requests. And what are the requests that has been present here? That is 3, because the number of ones in this mask is 3. That means these are the chosen requests. So we can calculate this pretty easily from the mask by using built-in countif function. built-in count function, and that will be our answer. So I'll just show you the code what has been written. So first of all, I just calculated the size of the request, and I initiated my mask as 0. Then I just pass solve request 00. That will find my all the masks, and I will store all the masks in my vector that is here. And I just go through if this is a condition that will end the recursion. If my that will I just simply push it to the mask, and then it will be simply take or not take one. And if I take this, then I'll just set the bit to 1. Then I'll just go into the mask, all the masks, and I create a two uh, in degree and out degree arrays, and just I iterate through all the requests. If I found this bit as 1, that means the request has been taken, so I just increase the in degrees, and I take a any bool f variable to check if any one of the requests has if any one of the room is not fulfilling that net flow equal to 0, then I'll just set the f to 0. That means it is not possible to actually take this request. This is not a proper request. So if my f equal to 1, that means the net flow from all the rooms are 0. That means we can take these requests. That's why I just simply take answer equal to max answer, and that's built-in pop count. What it does, it just calculate all the bits that are 1 in your mask. So it basically says that the request that you choose, all the requests that you choose, and we have to find the maximum request. So I'm taking the maximum of it, and at the end I'll just simply return the answer. I will show you the code is running fine, and here is let me just submit it. So it is accepted. And what are the all possible masks? That will be 2 to power 16 up to maximum, and I'm just going to this just for the n, and 2 to power 16 into n, that should be like 2 to power m. N into 2 to power m is the time complexity for this